record on this computer. It is starting to record. I will hit the start button. And so we are going to take off. We're already a few minutes past. Let's go. Shooba-doo-bop. First thing on here is counting principle. So this is, I think sometimes they call it the simple counting principle. Maybe that's just me. But I think I gave an example. Like if we have point here, point here, point here. And so this is my really simple example. I have, this is a town, this is a town, this is a town. And so like if I have 2 roads that go from this town to this town, and I have 3 roads that go from here to here to here, how many different unique ways can you count? From like city, I don't know, let's call it city A to city B. Or C. Let's do C. Here's A, B, and C. So how many unique ways can you get from A to C? That's not what this question is asking. This question is asking something else. But if you look, I can take this first road and there's 3 different paths there. I can take the second road and there's 3 different paths there. So there are 2 different ways to take 3 paths. You might have figured out. You do the total number of options here times the total number of options here is going to get you 6 different unique routes. So this is the counting principle. So what we do is we look at how many different options there are. So we look at how many different options there are. So we say something like what? 2 choices of salad, 8 choices of entree, 6 choices of dessert. I kind of set you up with what to do with those numbers. But how many different options are there for a 3-course meal? Okay. So this, they call it the counting principle. I think I mentioned it in the notes, but like when I was in high school and I worked at Whataburger, they had like, they had the number up there. There are so many ways to get your Whataburger. The easiest way is to think about each option, and you either have the option or you don't. So if you're like trying to figure out how many different ways, you just
we had to do like the whole tree thing, like, you know, like the multiple branches.
Yeah, I would just say like ketchup or no ketchup, right? Ketchup's one option. You either have ketchup or you don't have ketchup. You either have mustard or you don't have mustard. That's how I would do it personally. And so you're just multiplying by a bunch of 2s. However many options you got, it's going to be 2 to that number of options, right? It's 2 times 2 times 2 by ever how many options. I think the other way would be like what? There's more ways to do it, but you'd have to think about combinations. I was thinking about this. You do ketchup, mustard, mayonnaise. A person might think, hey, that's 4, but no. You also have to do combinations of mustard and mayonnaise, mustard and ketchup, right? And I think if you do 3, it's 2 to 3. There should be like 8 different combinations of those things. And it's easier just to do it in powers of 2. You either have it on there or you don't. This they're assuming so that you're going to pick something. So when we do a Whataburger or something like that, there's the option that you don't have it. Here we're assuming we're going to pick something, right? We have 2 salads, we have 8 entrees, and we have 6 desserts. We're going to pick 1 from each of them. So none is not an option here. We have to pick 1. So it should be what? 2 times 8 times 6, I think is what it should be if we do this. So we have stood on this long enough. Let's go. So I believe it should give you 96 different options if we look at this. I'll give you a breakdown. I think there's another breakdown slide. All right, looking good. And so we think salad, we think entree, we think dessert, and we think about how many are for each of those 2 and 8 and 6. And so you multiply each option. If they said you have an option to like not pick something, we'd have to add 1 to this, right? It'd be like 3 times 9 times 7, I think. So that's awesome. That's also another way to do it. And here we don't do combinations, right? We're not doing two salads. So the Whataburger example is a little bit different, but it's the same multiplication principle, right? We can think about each option. Use a theoretical method to determine, excuse me, the probability of the following outcomes in events. Okay, so I think I changed this a little bit from what the book says. I don't like the book's examples.
Yeah, the book example was like pick 2 kids or something like that.
Yeah, well, I don't really like it from a social standpoint either. Like, it's really horrible because it's kind of like assuming the like existence of people that do exist, or assuming that people don't exist that do exist, right? Like, there's a sort of false dichotomy with sex. There are intersex people and they do exist, and so like the book is just assuming they don't exist, and it's kind of really horrible to like just write someone out of existence. So I don't really agree with it from a moral standpoint. So randomly flipping a coin has the same probabilities, and we can talk about flipping a coin, and we can completely avoid writing people out of existence. But here we go. Use the theoretical method, determine the probability of the following outcomes and events. State any assumptions that you make. We're randomly flipping a coin twice, and we're getting heads up twice. So again, when we think about theoretical probabilities, we think about the event. How many times is that event going to occur out of the total number of times, or a total different outcomes that we can have?
So how do we notate our answer? Do you want it in percent or do you want it in fraction form?
So if you're talking about probability, you should never give a percent, if I'm being honest. It should be the decimal of it. So if you want to give the decimal, that's fine. If you want to give the fraction, that's also fine. I think I put both of them in there.
Okay, thank you.
Okay, so what I would do is like the solution set or all the possible outcomes. I would write out every possible combination of outcomes that this could be. Get 2 coin flips. Use H for head, T for tails. You can do it heads, 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 tails, tails, heads, tails, tails. So how many out of those possible outcomes, how many of those are double heads? I think in the next chapter we get a little bit easier way to combine probabilities, but I think right now listing out all the possible outcomes and looking at them is how we're just going to do this. Okay. So you should be able to list out all those possible outcomes. Should be able to figure out how many of those are double heads. So I believe there are 4 different possible outcomes. I believe one of them out of those possible outcomes. So it should be 1 out of 4 or 0.25. What are y'all telling me? 4 half? No. 0.25. Yes. Half would be a single coin flip, right? If you're doing a single coin flip, you get a half probability. It's going to be heads, half of it's tails. If we're doing 2 coin flips, we're getting 2 heads. We're getting a heads, tails, or tails, heads, or we're getting a tails, tails. And if we look at how many of those are heads, heads, there's exactly one of them that's heads, heads, right? We're only going to get that 1 out of the 4 times. It's happening right there with the double head. Come on, next bullet. So the probability that you're going to get 2 heads happens 1 out of 4 times. And so they talk about what, 3 different types of sort of probabilities in this. This is theoretical probability. They have relative frequency. And the third thing, I don't know, I forgot what they even call it. It's stupid. It's gonna be honest with you. It's speculative or something like that. It's kind of like not, it's just like, this is what I think it is. And it's like, that's not the best thing to do if you're doing science. I don't know how to say it. It's just not an accurate way to do things. I don't like it personally. So the local weather forecast has been accurate for 15 of the past 27 days. Based on this fact, what is the relative frequency probability that the forecast for tomorrow will be accurate? In this, you should reduce your fractions. So if you want to do a reduced fraction, I think I put that in there. If you put it to the nearest 2 decimal places, I think I also did that.
I'm not gonna lie, I'm not entirely sure how to do this one. Like how to figure out the probability on this.
It is very similar. Relative frequency is very similar to the theoretical probability, but theoretical probability, we're like making assumptions and we're predicting what's going to happen.
Okay.
Relative frequency, we observe what already happened. So if this has been accurate for 15 out of the 27 days total, what is the relative frequency that it will be accurate for tomorrow? We're assuming it's the relative frequency of how far we've been accurate thus far.
Okay.
So thus far, what is the probability that we've been accurate? So what is the probability, what is the occurrence that we've been accurate out of the total occurrences, I think, right? Is the way to say it.
It makes more sense to me now. Okay.
It is very similar, except one we're predicting. And so there's underlying assumptions, everything's equally probable and all this sort of stuff. We're making some sort of underlying assumptions to make a sort of prediction when we think theoretical. Relative frequency, we're looking back at like a study and we're finding the probability. Ah, man, I made it through so many statistics classes, finding the stuff. And then like, I got to grad school and then someone asked the question if like, does randomness really exist? And it's like, what? Of course it does. Yeah, I don't know. No, I don't know. It works. Probably confuse them more to talk about that. But if we roll a die, right? And we're going to assume it's equally probable for theoretical probabilities. We're assuming it's a random roll, but like it's not really random. If we calculate every vector force on that die, we can actually predict what number it's going to land on. So there's this question is like, is equiprobable or it being random? Is that just another word sort of for like ignorance of like what's happening? It goes into like, I guess that's probably more like philosophy, I think, is where it starts going into. And so y'all probably don't want to talk about that. But there we go, 5 ninths. What else are y'all telling me? 5 ninths, 5 out of 9.56 should be also be it. That's it. I didn't see. So this is a little bit different. I think that the suggested homework is 39. I want to do 41 because it's really good practice. I think I did this in the notes with the 6-sided die. So if we toss a 4-sided die, 2 4-sided dice. First, I want you to list all the possible outcomes and find the sums. So I'm trying to remember how I did this before I just like skip. But I want to think about all possible outcomes. So I think the easiest way to do it is to probably do it like this, like create a table. I think this is what I did in the notes. And so if I'm looking at this table, ooh, it's really big. Let's get a little smaller. Where is my fonts? Format, there we go. Let's go with 24. That's good. So this stuff up in here, 1, 2, 3, 4. You can think about this is like one of my dice, and like the other one is like my other dice over here. So my suggestion is to create a table like this for this problem. It will really help. And so the question, and I just skipped it, didn't I? They want us to create a probability distribution table. And they want us to create a probability distribution table for the sums that result when we roll 2 4-sided die. So for rolling a 4-sided die, we can have a 1, 2, 3, or 4 on the first die. We can have a 1, 2, 3, or 4. So my suggestion is to create a sorted table like this. Write the result of the die here, write the result of the die here. And if we want to find the sums, fill in the sums to this table. So here I'm doing a 1 plus 2, 1 plus 1. I'm doing 1 plus 2, 1 plus 3, 1 plus 4, 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4. So this is what I'm going to do. This is what you should do. I will give you a few seconds, like 10 seconds, 15 seconds, 14, 13. So I think the lowest number you have right here is 1 plus 1 should be 2. 4 plus 4 should be 8. So hopefully if you're rolling 2 4-sided die, I guess most of us are rolling. Usually you roll 6, right? 6-sided die. But 4-sided die, they exist. All the D&D nerds out there know. We get all kinds of sided dice. I've never played D&D. But let's clear this. So hopefully your table looks something like this. Here are my drawings. And so we know the sums are going to go from 2 to 8. And now we want to fill out a probability, what does it say? Probability distribution table. I think they said do a table or do a graph. We'll do a table. It'll be good enough. Ooh, excuse me. It was warm up. Okay, so I want you to fill out this probability table. You might notice a neat little pattern in this table. We get 2 once, right? We get 3 if you look diagonally. You might notice we get like matches diagonally. So I think we get 2 3s, we get 3 4s. If this is 4 by 4, I think there are 16 total different possible outcomes of how the dice might land. 4 by 4. I think if we count the squares, there's 16 of them. So if I'm looking at 2, I believe my probability for 2 should be what? 1
That's
out of
1 out of. Oh shoot! I should have added up everything before I spoke.
16.
Yeah. 1 out of 16. Okay.
Yeah, that's it. 4 by 4 is 16. There's 16 little boxes. If it was 6-sided, it'd be 6 by 6. It'd be out of 36. You get snake eyes 1 out of 36 times. We'd have a bit larger table. It would go from like 2 to what? 12. But it would be a very, very similar pattern. And we'll see it on the next page. But you should be able to do something like this. I think this is a better problem than the one that they assigned. Hint.
Yeah, I can confirm this is way better than the problem we were supposed to do in the book.
Yeah.
It was again one of those like find a family with 3 boys, and I was like, well, that's no help.
I don't think the probability that you're gonna have a boy or girl is 50-50 either. I think it's a little skewed. Because I think there's more females than males.
Yeah, you have a higher chance of getting a female than a male.
Yeah, I'm pretty sure.
Because all babies start out as females, but then testosterone is added, creating a boy later.
Yep.
But when no testosterone is added, it stays a girl. You can look it up.
I'll do that after class. I'll look up the percentage rate for that after class.
Yeah, I mean, I mean, it's.
I found that interesting.
That is, yeah, that's basically the kind of mechanism. There are more. You can have more sort of complicated things happening though too. Because there's XX, which is female with the chromosomes, and then there's XY, which is male. But you can have different combinations of those too. You can have like an XXY and stuff like that. It happens, right? Like,
you know, male calicos, they're called toms, and all calicos are meant to be female. So when you have a boy one, chromosome is XXY. I found that interesting.
Yeah. Another sort of interesting thing with the copycats, this is one I didn't realize, but nothing to do with what we're doing. But like the copycats that they had, the clones that they made of cats, they don't even have the same fur coats apparently. Like your fur coat isn't necessarily dependent upon your genetic structure. Or the cat's fur coat, I should say, not your fur coat. There's certain things that happen within the cat's life that can determine what its color code is.
I love moments like this. Like we'll be into whatever question we're doing, and then all of a sudden we get into something completely different, and it's like, wait, and then it just snowballs.
I hope you figured this thing out. So this is what I want to ask. What is my sum here? If I sum all this up, if I sum up my probabilities, what should my sum be? This is a good way to check your tables. And I did 1/16, I did 2/16, and also 1/8. But sometimes it's easier not to simplify your fractions, because if we want to figure out what this sums up to, we're going to add what, 1/16. It's a lot easier to add 1/16 and 2/16 than to try to think about 1/8. So I got to convert that to the same denominator. That's too much work. I would just keep it in the 16ths probably here. But what if I sum all these up? What is it going to sum up to? One and 2 and 3 and 4 and 3 and 2 and 1. If I add those all up, what do they add up to?
Wait, so we're just adding like all the numerators up, right?
Basically, yeah. What are those going to sum up to? What should they sum up to?
I did something wrong. Hang on. Sorry, my calculator was pulling a dumb. Should be 16 still, right?
Yeah, it's 16 out of what? 16? Which is what?
So it's a whole? 1?
1. That's 1. It's 100%. That's everything. That's what we're saying. The probability that you're going to get a sum from 2 to 8, you're going to get a sum that's from 2 to 8, right? The probability that's going to happen is 100%. You're going to get a number from 2 to 8. So if we add up the probability of every different occurrence, it should be 100%, right? You should have one of these occurrences if you roll 2 dice. That's what this is saying. So if we sum up our probabilities in our probability distribution table, we should be summing up to 100% if we accounted for everything that could possibly happen. Okay. Questions about this? You think you could do a graph with this thing?
I don't know about graph, but table for sure. Yes, I can absolutely do that now.
Like
Mhm.
we did this, and this is my probability over here. This is my occurrence. Either I get a 2,
For
3,
some reason, it
4.
reminds me of 3rd grade, and they place a bunch of colored teddy bears, and they're like, "This find the probability of grabbing one of the colors."
Oh, like the marble thing. Like there's this many colored marbles. What's the probability? Of
Yeah, we're about to do those.
Ah,
And so your probability should look something probably like this, right? It's going up and then it's going down, right? And so if you notice it, there's one way to roll a 2, there's one way to roll an 8. We get 1/16 on both of those. I don't know if you notice this has a certain symmetry to it, right? Is what I was trying to get at. When we do these sorts of rolls and summations, you're really, really likely to roll the things in the middle, like a 5. And you're less likely to roll the things on the outside, if that makes sense. What was that? There was this game with like you roll the pigs. I don't remember what that was. But you got different points for different things. And it said if you rolls one way, it's like you cheated. You get 0 points. I remember that game. It's like so rare. And I think they even had the solution covered. And then when you open it, it's like you get no points. You cheated. It's like, oh, okay. It's like if they both land snout down or something. It's like there's no way you did that. Okay, so this is the definition of odds. So it's almost like, I want to say this is almost like 100% sort of like vocabulary sort of thing here. It is a weird vocabulary. It's something I guess we got to get adjusted to. So using the definition of odds, and to be honest, I'd probably have to look this up for a second before I look taught it again. But if we're betting odds in betting, the odds on or against your bet are 3 to 5. And so they say if you bet $20 and win, how much will you gain? So with the vocabulary, odds are read kind of backwards. So if you bet $5, you're going to win $3 if you win. So if I bet, $5, so let's say I bet $5 on whatever the heck they're playing here. I'm going to get my $5 and I'm going to get $3. So I'm going to get my $5 back and I'm going to get $3. So when I go back to the teller, he better give me $8, right? But I'm winning 3. So if that didn't confuse you enough, what are we saying? So for every $5 I bet, I'm going to win $3. So if I bet $20, how much will I win? And so how do we go from 5 to 20, I think is what they're asking. And how do you go from 5 to 20? These should be in the same sort of ratio. So if we're betting $20, you'll get the $20 you play back, but you'll also receive what in prize money? Like how much will you net?
So we're gonna type in like the total amount of money we would receive
So how do we go from 5 to 20?
times 5. I mean times 4.
Yeah, exactly. And so how do we go from draw a horrible arrow? But that's it. So maybe I'll ask another question after we answer this. Or maybe I'll just tell you. I think this is in dollars, so I think you do have to put a dollar sign. Are we? Yeah, I think it's in part C we start going over expected value. I might be wrong. So we will figure out what the best game to play in the casino is. Y'all know that one? Find it with the expected value. Does anybody know what the best game to play in the casino is?
No.
Slot machine.
Is it slots?
Oh, this is like they don't call them one-arm bandits for nothing.
Poker?
You saying for like odds or just the most fun to play?
I mean, like as far as odds and probabilities goes, that you'll win.
Mm,
The marble game?
I'm tricking. I'm being a jerk.
What is that game? The one with the marble. Like you spin
Is
the
it-
thing, let the marble go.
Roulette.
Places
Roulette? Okay.
Yeah.
Roulette's probably the best. Best odds you'll get is 50-50.
The best game in the casino is the one where you put your dollar in and it gives you 4 quarters back. That is the most fair game in the casino. The cash change machine, yes.
Yes, James.
The change machine.
Imagine if people just went into the casino just to get 4 quarters and then left.
I mean, hey, converting money, you get free drinks. I mean, what more could you want?
Like casinos are not there to lose money. Like the expected value of each game is negative. You're expected to lose money if you go play in a casino. Like the only way you're gonna like make any money, you're not even gonna make money. You're gonna keep even, right? If you use the change machine.
Imagine
Even if it
people-
malfunctions and doesn't give you your change back, maybe we could put a negative value on there. But
Fun fact, I learned this in trivia. There are no clocks in a casino.
that's probably true because they want to kind of disorient you and stuff.
Yeah, that way everyone's looking at the time like, oh, I gotta go home, and so it keeps you there longer.
Yeah, so
It's like a psychological thing.
5 times 4 is going to get me to the $20 bet. So if I'm doing this by a multiple of 4, I'm also doing this by a multiple of 4. 3 times 4 should give me 12 or $12. If we go back to the teller should be giving us $32 back, right? Or whatever they do. They should be giving us the $20 back that we bet, and they should be giving us back the 12. So you should be netting $12. You should be getting 32. So if they ask you how much you get back, it should be like 32. So you have to be careful maybe what question they're asking there. Decide which method, theoretical, relative, subjective. That was it. Oh God, don't do that. If y'all tell me subjective, I'm gonna cry. Subjective is like, I think this is it. I don't think we got good odds of getting married or something like that. It's just like
I'm gonna put suggestive just as a joke.
Not knowing your favorite group. So I think we talked about this. Are we assuming something based off of, are we making assumptions and coming up with a probability, or are we looking back on something and saying something about what happened? Are we making a prediction about what's going to happen, or are we looking back and saying something about what has happened? I think are the two distinct sort of ideas there. Subjective is so silly. I don't even know I have that in the book. It's like, I think this is going to happen. That's not what we're doing. I'm interested in objective truth. Oh, come on, this is 50-50 between those first two.
We have a 50-50 probability of getting this right.
Where are we at on slides? This is a pretty... They don't give us a whole lot of problems in this section. But we do get 4 different sections over probabilities. And we do probabilities, and we do combinations of probabilities tomorrow. So it's a little bit of the same thing with more attached, if that makes sense. And we're about halfway. That's pretty good. I think I would say this, I think I said was theoretical. We're looking at our playlist. We're making assumptions, right? We're making assumptions that these are all, why else saying relative? So we're making an assumption that each of these 127 are by my favorite group. we're making an assumption that each song is equally likely to play, right? You're making predictions about what is going to happen. So not hearing your favorite group on a random shuffle of your playlist that has 889, of which 127 are your favorite group. I guess I could see why you might say that's what relative frequency if this had happened. Yeah, I guess it's not too clear. I don't think the back of the book specifies which one either. But you should not do subjective on this, definitely, right? It depends how you reason this. If you're making a prediction about what you're going to hear, I think it would be theoretical. If you're doing what already happened, right? If you listen to music for so long, I think that's where the relative frequency would come in. Say like I listened to it all day and I didn't hear one from my favorite group. What are the odds of that happening? If it played 889 songs, or no, it wouldn't have played that. Would it play like so many songs? If I played so many songs and I didn't hear it, what's the probability of that happening? I think that's how you'd have to do relative frequency. This seems like it's trying to predict what's going to happen when I listen to my songs. That's the way I read it personally. That's why I said theoretical. But I think the important thing is that you know the sort of distinction between what these is. This may be not the best example to distinguish them. Theoretical is predicting what's going to happen. Relative is looking back on a study. You're looking what did happen. And they're being a little bit tricky here, maybe. 127 are from your favorite group. You have 889 total songs. But they want the probability of not your favorite group. So how many of these are not from my favorite group? Okay, so there's 889 total, 127 are from the favorite group. What am I getting? 762? I think 762 is not the favorite group. So what is that probability? And if you give me a really big fraction, you're partly correct, but not all the way. You probably want to reduce that fraction. A lot of your calculators have that too, where you can do it. What I'm talking about? They have that key that says frac. A lot of times that will do it. If I do, let me see. Can I show you all this? I'll just show you. That'd be the easiest way. All right, so let's go. Let me show you on this. TI Smart View, that's the one I share. So this is my TI calculator. So I said there are, what, 762 out of, what did I say, 889 total songs? So I guess if you give me like 0.86, that's good. But if you want to look under in the TI calculator, if you hit this math button, it's this first option that says fraction. and you can convert decimal to fraction, or you can convert fraction to decimal with those options. You can do the decimal one. But it's just under the math key in the TI calculators. A lot of calculators have this option. Maybe Google it. If you don't know, I don't know. Usually, like if you Google your calculator and what type of calculator and what issue you're having, you can usually find something, or at least you can find a manual on it. It'll tell you how to do it. So I just gave you the solution, didn't I? Any questions about this? A lot of these calculators have the frac option. They're just not in the same place. So, okay. Let's go back to quizzes. If you didn't answer this already, I feel sorry for you. I think I gave you both solutions that are possible. Like 6/7 I think is the preferable one, right? If you don't have to round stuff, we really love that accuracy. 6/7. What was you telling me? 6/7.
It says I'm 5th on your leaderboard, but I see I'm 1st. Weird.
I completely forgot to like divide and like do like the second step. I was like, all right, that's the number, that's it. And I was like, wait, no.
Yeah, I was being really picky on this one too, because 762 out of 889 is absolutely correct, but it needs to be reduced. Yeah, so I think that's what happened, is like just didn't reduce the fraction. And I'm being really picky. I'm being honest about being picky. But if we want to know, this is what I did already. So if we have 889 total, we take away 127 that are from our favorite artist. There are 762 that are not. So the probability that you won't hear something from your favorite group is 6/7. So if I go select one song, there's a 6/7 chance it will not be my favorite group. Questions? All right, so now we're doing a marbles. I'm gonna lose my marbles. Suppose you reach in and draw 2 marbles at random from a bag containing 10 white marbles, 10 black marbles, and 10 red marbles. The first thing is we want to list all possible outcomes of this process. For example, red, red, black, white. I would not probably start that way. I think I start with double white. So my hint, I guess, if I want to give you a little bit of hint, start with white, white, go white, black, white, red, I think is what I did. So I did everything where white can be first. And then I want to do everything where black can be first. And then I want to do everything where red can be first. And hopefully there you see maybe some sort of pattern that might help you. If not, maybe not. But I think we'll get 3 different options for the first marble. I think we'll get 3 different options for the second marble. If I think about 3 and 3, I think I should be getting 9 different possibilities. So that multiplication principle, I may not ask you for it directly, but like it comes in, right? It tells you how many things you have. We did that back when we did true and false too, right? True false has 2 possibilities. True false here has 2 possibilities. 2 times 2 when we have 2 different propositions. There's 4 different possibilities. When we got 3 propositions, there's 8. So I remember doing that counting principle way back when. I told you it was useful then. Probably said it'd come back later. Now it's later. All right, so what are we doing? How did I have y'all answer this? Is this the open-ended shit?
Yeah, this is the open-ended one.
Okay.
I'm just trying to figure out how to do the second part. Make a table or is that like the next one?
Yeah, we'll go through that in a second. Just do all the possible outcomes.
Okay.
I think I did a table again, just because they're easier to do in here. And usually you construct a table before you construct a graph, especially if you're doing events like this, like I would. I would construct my table, and then I might even like just get Excel to just construct the graph for me. I don't know, but it's not too hard to construct these graphs. I'm not expecting pinpoint accuracy. I'm expecting it to be relatively accurate. That loaded word, relative, whatever it means. What are y'all telling me? That's exactly what I did, Jasmine. We're good. Yeah, you probably copied. The back of the book did the same thing too. So yeah, I don't know if y'all are actually doing it. I hope you're doing it. Should be 9 possibilities. I'll give y'all like 30 more seconds. I know this takes a minute to type in. I feel like I get like so much tension in my neck and shoulders now. I think it's just like staring down at the computer all the time. When I was a kid, you go in like the Walmart or grocery store or wherever, and they always had like the Nintendo and set up, and it was like way up high when you're a little kid, so you're just like standing there for hours playing a new game, and then like you get that crick in your neck. I don't know if you ever did that. But that was the thing when I was a kid. They had like the really high monitor, and you're like a little kid, and you're looking up the whole time for hours on end.
Yeah. I remember one time in like we took a class trip to the movies, and my entire class was seated in the front row. So we were little kids just staring up at the screen for an hour and a half.
Was it?
The minute the lights come off, like we're all blind and our necks are hurting, and we're like, okay, we're never doing this again.
Yeah.
From that moment on, my family became a back row only.
Yeah, the only way you're gonna sit on the front row and not get a crick is if it's like one of those recliner seats. But then you run the risk of falling asleep during the movie that you paid for. So I don't know. Usually front row ain't favorable. I've been there. Was it IMAX or was it normal movie?
I don't know. All I remember was like the Tale of Despero, like the one, the mouse with the giant ears, and like we had a front row seat, and we were like, okay, as much as I love not being in school, this hurts.
What I hated was like I was really small, so whenever I sat on one of those like flip up chairs in the theaters, it'd always eat me.
Oh my god, same. I was a tiny thing. Still a tiny thing.
So we need to get this thing down. So there are like 5 people that are slacking around. I hope you're getting something down on this. I hope you're understanding what's happening. You should be writing 2 letters, and there are 3 different letters, possible letters for each. So there are a total of 9 different outcomes. So this is what I was talking about. I want to think about everything where white is first. White, black, white, red. Next thing, I want to think about everything where black is first. So I go black, white, black, red. WBR is my pattern. And now I want to think about everything where red is first. So I do what? Red, white, red, black, red, red. Questions about these? How we write these out?
Confused about that because you're repeating some of them, right? Like on the white, you have white, red, right at the end, and then on the bottom it starts with red, white. Oh,
so just that is good to notice. So the order that we pick these out matters, right? If at first I pick a white and then I pick a red, we're looking at it differently from picking a red and then a white.
Okay, got you. Thank you.
And this is something called permutations versus commutations. I forget which is which, if I'm being honest. I would have to look it up. I believe permutations is where order matters, and the other ones where order doesn't matter. Permutations and combinations is what they call them there. So I had to refresh myself on which is which. I guess let's do it. Permutation. Order matters. Order matters on permutations. So these would be permutations. If we didn't care about the order, right, we would have to like kind of mark through these. We'd have to look. So there are 9 different permutations. Like you're saying, white, black, and black, white would be the same then, right? White, red, and red, white would be the same. So we have some that would like, if we didn't care the order of these, they would absolutely be repeats. But order here is important. So black, red, and red, black are the same. And I think we would have 3, 4, 5, 6 different combinations if we thought about the combinations that we could pick. That is a good question. Yeah, I don't know if the book talks about those. I think we're just doing all the different combinations with order mattering. So what does this say now? We want to do B. We want to make a table or graph. Did I do this as an open-ended question? I thought I had it like kind of set up for you. Maybe.
Yeah, it's an open-ended question.
What did I do? I forgot what my slides were on this one. Let's see. Oh, it's too much. Too far. Going too quick. I think this is right all the different possibilities. So there were 9 different possibilities. We want to count how many of them?
It's
Do we
9.
want to do a table? I think I'm going to go backwards and look at my combinations. So now if I want to do a table, it'll be the easiest thing to do. We do 0 black. We're doing the number of black in the table, right? And 1 black. So we either have 0 black, 1 black, or we can have what? 2 black is the most that we can have. So these are my events in this. I want to find out the probabilities. So how many different ways can I get 0 blacks? 0 black marbles. Let me get my drawing here. 0 black would be here. There is no black. I believe here there are no black. Here,
It's 6.
I believe there's 4 of them I can get, right?
Oh wait, yeah, 4. I forgot the whole row is black. One of them.
And now let me get another color, blue. Now I want to do 1 black. I believe this one has 1 black in it. I believe this one has 1 black in it. I believe this one and
5.
this one. How many? Just
wait.
1.
4.
Yeah, just 1. And then we want to do 2 black next.
So now it's 1.
Now we just get 1 in the middle there. We do. And so my table should look something like this, but maybe a little prettier than what I'm doing because it's on a computer pad. But that's basically your table right there. Are there questions how we're getting this probability distribution? So we have to look at the events, which are going to be a little bit different from the outcomes. So when we talk about outcomes, we mean like everything possible. When we talk about events, we're looking at the outcomes to find the event, if that makes sense. We're like 0 black. How many of these things have 0 black in them out of my outcomes? And again, let me clear this and go to the next prettier slide. So the next one. Yeah, whatever. I know none of y'all answered. It's fine. You got to make a table. We pretty much made the table. And again, I'm going to ask the same question. What does this sum to? If I add all my probabilities,
9.
9 out of
9 out of 9. So 1.
exactly. So this is the 100%. If we think about it, we're either going to get no black marbles, we're going to get 1 black marble, or we're going to get 2 black marbles. If you're drawing marbles and you get 2 marbles at a time and you get something else other than this, you're beyond me. I don't know what you're doing. You have to explain that one to me. You should get one of these, right? If we draw 2 marbles, there should either be none, there should be 1, or there should be 2 that are that color. We could do this for pretty much any color too. I think any of these colors are pretty much interchangeable. We had like 10 of each. Okay. Questions about this? How we get this table? Do you think you can make a table like this if I gave you a problem like this, hopefully? Is this doable? I hope so. If there's questions, now is definitely the time to ask. Okay, so we are almost done. I think this is the last problem. Have to look at this table. What do they ask? Suppose you encounter delegates. What does the full question say? What is the probability you meet a man? So I'm going to look at this table. If I add all these up, they were really nice, but if you add everyone up at this convention, guess what number they're going to give you? It is a really pretty number. So if we do 21, 25, 6, 28, and 16,
100.
you're going to get 100 people total. So now we want to know how many of these people are men. What's the probability you will meet a man? And so you can write that as a fraction. You can write that as a decimal. Either way, you should be giving me like an exact solution on these. Let's divide by 100. Right?
This really is a good number to have.
It is really pretty, yeah. This makes it so easy. 100 people total. Get out of here. Annotations. What is the probability that you meet a man?
I reduced it and then my rank dropped.
All right, so what should you be adding here?
All the men together.
All the men together. 28, 16, and 4 is going to give you what number?
48.
48.
And so this is what, 48 out of 100 or
100.
0.48?
And simplify it. You get
Simplify. 48 out of 100. Oh, I didn't simplify it at all, man.
Weird, right? Like you get the answer right and then your rank drops.
Sorry, yeah, it's 12 out of 25.
Right, but it wanted the
Weird.
decimal.
Yeah, I didn't do it. I didn't reduce these. Don't reduce these.
Oh, okay.
I probably should have, but I didn't.
That's no right.
12 out of 25 is also the correct solution. If you got 12 out of 25, pat yourself on the back. Y'all are my guinea pigs now. I flip my classes around, kind of. My other one had an extra little day in there compared to y'all, so they got an extra day on it to review. And so that's just the way they made the classes. There wasn't nothing I could really do. But now y'all are the ones leading the lecture, and so now I'm making all these mistakes. I got to make them on your behalf. So you're welcome. So A is also what, 12 out of 25. I can write myself little notes over here on my board and maybe fix it later before I go and talk to them. I believe there's E in this one. are 5 different little things we got to figure out. What is the probability that you meet a Democrat? And so I hope you all like kind of realize this. I know I said it in the notes, but if I give you 0 probability, what does that mean?
0 chance.
Yeah, it's not going to happen, right? If I tell you it's a 1% probability, what does that mean?
1 chance.
Yeah, it's giving you like a percent basically, right? This is a 1, this is a 100% chance. So we're doing basically the decimal equivalent of a percentage. It's kind of like what probability is. It's like the decimal. It's a percentage, but it's expressed as maybe like a decimal. Maybe a good way to think. And so it gives you the chances of something happening, right? All right, so we're doing Democrats here. I don't think I broke these down. So if we're looking at Democrats, I hope you're looking at Democrats and only Democrats. I hope you're looking along here. If they tell me Democrats, I narrow it down just to that line. If we add those 2 things together and divide by the total number of people, what am I getting? 41, I think is what I'm getting. Oh, 1 person's asleep. What are y'all doing? Or 0.41 if I divide it by 100. 41 out of 100, does that even simplify? I think 41's prime. So I don't think it does. No. What else y'all telling me it would be wrong? Did you add wrong? What is the probability you do not meet an independent? There are a few ways to do this. So I think this brings about some good points. Oh man, I didn't put my 0 in front. I may not count that right. I didn't think about the leading 0 in front of the decimal.
Yeah, I missed the leading 0 too, and it dropped me.
Yeah, I need to get more picky about that. Because I'm getting more into programming, and it's like that is an issue when you do programming. You have to put the 0 in front of the decimal. I think I usually do in my solutions on here. Putting things in your phone is just kind of awkward anyway when you type stuff on your phone. It's so much easier to do it on your computer.
Agreed.
All right. So the probability you won't meet an independent. There are 2 ways I can think about doing this. Like kind of off the top of my head. How many of y'all went and you looked at everyone that wasn't an independent? You said 21, 28, 25, and 16?
I did. I definitely did that.
You did that?
I just ignored the independent.
That is
row.
absolutely correct. That is not what I did. There's an easier way, and I don't have to even, I can do this in my head if I do it the easier way. Maybe it's not easier. But if I look at this, there are 10 people that are independent. There's 90 people.
10 minus 100.
Yeah.
Okay.
That's what I did. It's totally cheap, but you can think about that, right? You think about the totals. It's like everything that's not this is this one. Think about these separate sets. Oh man, did it hit enter? What happened?
Oh.
That's weird. Is it timed?
Yeah, I don't. Oh wait, I think all of us
Oh,
answered. Did all of us answer?
Yeah, that's probably what happened. Yep.
I think that's the first time that's happened.
Congratulations.
Woo!
It should be 0.9, right? We got 90 people. We divide 9. We get 0.9. I got it incorrect because I didn't put my 0. Okay, questions? Looks like y'all got it right. Except for maybe one person that wasn't me. What are we asking now? Part D. What is the probability you will meet a male Republican? Okay. This is being very, very specific. It is narrowing things down quite a bit. We did these back when we did these things. Remember these things? These Venn diagrams? We could probably say that this is what men, and we could put all those numbers in there. If it's not men, it's got to be women, men and women. If it's, well, oh shoot, we'd have to do Republican, Democrat, and Independent. No, it'd be more complicated than just it's. If we didn't have independents in there, we could do, if it wasn't Republican, it was a Democrat or something. Reinforce the false dichotomy of the political system. Remember, we had those tables, though. We converted tables to Venn diagrams. You could do it here. I think you'd have to have like three bubbles. Okay. This one is asking for something very, very specific. They say it has to be Republican and it has to be man. So if I'm looking at this, what is in both of these things I circled?
28.
28. So there are 28 men Republicans. So what is the probability you will meet a male Republican? 0.28.
28 out of 100.
Yep. That's it. What else? Tell me, man. What was this? 28 out of 100. That's it. 0.28, 2.28. What is it counting wrong? That's what I want to know. Were y'all answering wrong? Ooh, 21's not right. Okay. 0.28. Okay. Yes, you answered correctly. It's just being really, really picky about the 0 in front of the decimal. And I think this is the last question, although there might be one more. I don't know.
This is the last one.
Okay, yeah, it does say the slide numbers on your thing, doesn't it? What is the probability that you meet someone that is not a female? What is the probability that you meet someone? Woo! That is a copy and paste, and it copied and pasted it twice, apparently, right? It does that sometimes. I don't know why it does it. I didn't catch that. What is the probability that you will meet someone who is not a female Republican? And again, these are women. Let me get a different color. I don't like this yellow color that much. This blue is a nice color. These are the women. These are the Republicans. So if I'm looking at where these things cross, I hope you're looking like right there and there in the middle for this 21 female Republicans. So if I meet female Republicans, it would be 0.21, right? And again, there are other ways you can do this. If you wanted to add up all this stuff and figure out what the heck that probability was, you could do it that way. That is not the way I would do it personally. I would think about, I have a 100% chance of meeting one of these people if I meet a person here. What is the probability that they will not be this? I would take it away from the whole set, if that makes sense. And so what I'm kind of saying is I get what 100% is one probability. And if I want to meet a female Republican, it's going to be 0.21 probability. And so if I subtract the 2-1 probability from guaranteed to meet someone, right? I think I should be getting the 0.69. Did I answer that? I hadn't answered. I'm probably the last one to answer. All right. That is it. Any questions? Hopefully you can read some sort of table like this.
We ended on time.
Yeah. Yep.
I believe we have 2 minutes to spare.
Good job.
Good job, us. Virtual
Yeah,
high
this
five.
section's pretty short, so definitely get this stuff down. If there's anything you don't understand, like now's the time to ask, because we get to the next section, we're gonna start combining these. It's gonna be like we're just gonna assume you know this, all of this, everything in this section. It's gonna get more. We're gonna do this, but more.
I'm
So get
actually
this-
happy. This was always the one subject I was good at in math.
This is.
I
I know
remember.
too much. I can't remember if I said this in the notes or not. But the guy that really developed like probabilities and statistics, his name was Cardano, an Italian guy. He was a really big gambler.
Of
Of course, it's the gambler.
course. Of course the
But-
gambler finds the probabilities.
Yeah, I mean,
Because
it
he
makes
wants to
sense.
win. He wants to win all the money.
It makes sense to some degree, but also, I don't know, man. When I got my degree in statistics, it definitely took me a couple of years to even want to step foot in a casino. It's like, you know the gimmick and you know they're going to take your money. I have been in casinos like a handful of times. But I always go in expecting to lose money. I go in to play a game, basically. And I expect to lose money on the game.
You just stay
like-
at the slots.
I view it like kind of going to an arcade that I might have a potential to actually get some of my money back. It's like,
I just bet a penny in poker or blackjack and say, "Here's how much I'm betting," and the whole table just looks at me and goes,
Are you insane? That's it? Listen, man, that's all I got.
I just had a natural curiosity. I had to go look at casinos. It's like it's a big light show. It is pretty, but
It's definitely one of those things. It's like, I want to go. Will I do something? Probably not.
okay. I'm gonna stop.